another one, this one with tangent. So we got the inverse tangent of the tangent. Okay, again, if this number 11 pi over 2 is in the range of inverse tangent, then we're done. So inverse tangent can output anything between negative pi over 2 all the way up to positive pi over 2. All right, but 11 pi over 2 is way over here. It's almost pi. You can again do it with your calculator and see it's bigger than pi over 2. So once again, it's too steep. But here's the thing. It's not like with sine, we had to go straight across and say, all right, so this is the angle that would do it. That gives me the same y coordinate. Well, tangent is not a y coordinate. Tangent is the slope of this line segment. And so if I follow that line segment through the origin out the other side, it's going to be this angle again, because it has to be a negative angle since we're down in quadrant 4 that produces that value. So it's this negative angle that we're after. That would be the output of the inverse tangent here. Again, it has to be in quadrants 1 or 4, and if it's in quadrant 4, it has to be negative angles for it to be output of the inverse tangent function. So what we're going to do is take this 11 pi over 2 and subtract pi radians, and that will put us in quadrant 4, giving us the angle that we want. All right, 11 pi over 2 minus pi, 11 pi over 12. Well, pi is 12 pi over 12, so that would be negative pi over 12. So that's the angle that we need that will come out of the inverse tangent if we feed it the tangent of 11 pi over 12, if we feed it an angle bigger than pi over 2 here. All right, now let's look at the TI and do it that way. So again, inverse, let me clear out everything. Inverse tangent is second tangent of the tangent of 11 pi over 12. All right, close that off, hit enter. I'm going to divide that by pi, change that into a fraction. All right, and remember, stick the pi back in. We divide it out just to get it in the fractional form, and then stick it back in, and that'll be the negative pi over 12.